Hi, my name is Diego Martinez Cardenas, and for the first few minutes I'm going to walk you through my weather data analysis project. This is a modular object-oriented pipeline that ingests, processes, visualizes, and even predicts weather trends. The first thing that I want to be talking about is the data ingestion methods that I used for this project, that we can find them in the data loader file. The first one, it's the loading files using Python's built-in CSV reader. This one returns a list of rows if successful, otherwise returns an empty list. It's simple, transparent, great for small files and learning purposes. The next one, we have the pandas approach. With this line we can load the entire database into a data frame, giving us powerful filtering and grouping capabilities. And lastly, we can use the PySpark integration, and then with this line over here we load data in parallel across multiple cores or nodes, then convert to pandas for downstream tasks. On a README file we can find all the information of the project. As we can see over here, we have the data set that we have it here containing this data set path. This is one of the most important parts of the project, because we would not be able to process any information if we don't have information. Here's the project structure that you can also see over here on the side. To install, it's necessary to have Python 3.7 or higher. Also Java is used for the PySpark module. And here are all the libraries that are needed to install and run this project. Here's a small step-by-step on how to do it. And in the usage, as you can see, the only thing that to run the script, you can do it from the terminal, or what I'm gonna show you right now, I'm just gonna run it here. It might take a minute to load all the information, but it shortly we'll be able to see how PySpark helps us visualize this data. Additionally, one of the last pictures that we're going to be seeing is the ML model. This is something that was included in the very last part of the project. As we can see over here, we have the first graph that is showing us the daily maximum temperature trend. If we close it, it's gonna give us the next one, that is the distribution of maximum temperatures, and here, as we can see, it's pretty easy to analyze. Additionally, we can change the way this is presented if needed. If we close it again, we have the hot days scatter plot. Same thing as before. With all these things we can change whatever we need in the graph if needed. And then finally, our last graph is the one using the ML module, that also predicts using AI the heat wave scenario and what's going to happen compared to the regular one. As you can see, there is a significant difference if we have a 10-degree spike. Here's my main file, as well as the README file that contains all the information, and some expected outputs whenever you run the tests, that we can see over here. For this project, I use the object-oriented programming principles for my design and some of the features that we see over here. This is very important because it makes it easier to maintain and reuse it in the future whenever it's needed. Thank you so much.